In this video, we'll discuss the quotient rule, another shortcut rule for differentiation. First, caution. Curvy road ahead. If f is defined as the quotient of two functions, u of x over v of x, where v of x is non-zero, then the derivative of that quotient is absolutely not the quotient of the derivatives. Okay? So in other words, the derivative of the quotient is not the quotient of the derivatives at all. And I've written a skull and crossbones here, so that's not true. Okay? There's another rule for differentiating the quotient of two functions. So here's the actual quotient rule. If f is defined as the quotient of two functions, u over v, where v is non-zero, then the derivative of the quotient of these two functions is given by this expression. The bottom function multiplied by the top function minus the top multiplied by the derivative of the bottom over the bottom squared. Okay, so in this case, it does matter what order we differentiate each one. Okay, and the bottom has to be squared. So this one's more complicated to remember, and I have a little way to remember it written down here. It's a little song you can sing. And that is, you think of low d high minus high d low over the bottom squared we go. Okay, this is just a way to remember how this actually works. Okay, here's low. Here's low, low, d high, there's the high, minus high, which is u, d low, there's the derivative of the low, over the bottom squared. Okay, so that's the quotient rule. And the proof of this is exactly analogous to the proof of the product rule. So let's do some examples of the quotient rule. Again, we just need to identify the different pieces and use the rule that we know. So let me start with the first one. Here's my example. Here's f defined as this quotient of two functions. So again, to differentiate, remember that we just look at the different parts, top and bottom, high and low. All right? So in particular, this top function is really like my u of x, and the bottom function is like my v of x. Okay? So again, we go ahead and differentiate knowing our little rule, right? It's low d high minus high d low over the bottom squared we go. So first of all, it's going to be low, then d high. So low first. Low is 1 minus t. That's the low function. D high, derivative of the high. So low d high. Derivative of the top one, again, this is just a poly. So the derivative of this is, well, the derivative of each piece. Derivative of 9 is 0 because it's a constant. And the derivative of 7t is just 7. So you get minus 7. So low, d high, minus high. High is 9 minus 7t. High is the u of x I've written up here. D low. So the derivative of the bottom now, derivative of the v, is just going to be a minus 1, right? Because again, it's a poly. The derivative of 1 is 0. So I get minus 1. Over the bottom squared we go, so I just square the bottom, the v. So 1 minus t quantity squared. Okay, and so once we simplify this a little bit, we can see that first in the first term up here, the top, I get a minus 7 plus 7t minus, well, make that a plus because the negative multiplied by the 9 here. So I get a 9, and then I get a plus 7t. Well, actually, I'm going to get a minus 7t, aren't I? Because I've got a minus, which makes that a plus, and then you have another minus. There's 3 negative signs. So actually, this will be a negative 7t. And on the bottom, we have a 1 minus t quantity squared. This is really nice that there was a negative 7 there because, look, those cancel. And so in the end, when all the smoke clears, we can only go so far when we simplify. And it looks like we just take 9 minus 7. So I get, what, a 2 over 1 minus t squared. So there's my derivative right there. 2 over the quantity 1 minus t squared. And we just used the quotient rule identifying the different pieces. And the way that I remember is just low d high minus high d low over the bottom squared. So now let's do the second example. I've got g as a function of t. Again, it's just a quotient of two functions. All we've got to do is identify the top and the bottom, the high and the low, and go ahead and use our rule, our shortcut rule. So again, g prime of t is going to be a quotient. Identify this as, well, this is the high, and this is the low function, right? So remember, it's low d high, so low first. Here's low. D high, well, first of all, I can write this as t to the 1/2 power, right? So low, d high. If I differentiate this using the power rule, the 1/2 comes down, t to the minus 1/2. 1/2 minus 1 is a minus 1/2. So remember, it's low d high minus high, which is root t. D low, well, the derivative of this is just going to be 1, right? Because the derivative of 1 is 0, and the derivative of t is 1. Over the bottom squared we go. Right, so square the bottom. Now, I'm going to go ahead and massage this a little bit to try to simplify as far as possible. So first of all, I'm just going to leave everything and sort of expand the top, the numerator. So t minus 1 squared, right? So what do we have? We have, if I multiply these two first, I've got a, well, this is a t to the 1 power, and this is a t to the minus 1/2 power, right? So 1, and when I do that, remember that I have the same base, I add the exponents. So I'm going to have 1 minus 1/2, which is a positive 1/2. So t, well, there's still a 1/2 here, to the positive 1/2. For the second part, it's a minus. This is going to be 1/2 t to the minus 1/2. You see that? I multiplied those two. Then this last one, we just still have just a root t is all. Well, look, root t is really t to the 1/2. So that means that in many ways, well, exactly, I can combine these two. I can combine this one and this one because they have the same base. 1/2 of something minus 1 of something is a minus 1/2 of that same something, right? So let me write that down. So I simplified a little bit. The bottom is still t minus 1 quantity squared. Again, I'm going to have a minus 1/2 t to the minus 1/2. But when I combine these, I have a minus 1/2 of t to the positive 1/2. Okay? And now I can actually combine just a little bit further, right? I'd like to massage this a bit more because I don't really like negative exponents, and I'd like to get rid of them if I possibly can. So notice that, well, if I write this in terms of roots, maybe you'll see a way to simplify this. Okay, see how I'm going to do it. So let me erase some stuff and just kind of massage this. Now, I have my solution. I mean, this is the answer. I just want to write it in a sort of more simplified form. Okay, so let me erase up here and simplify this a little further. Okay, so what do we have? Again, the bottom is the same, t minus 1 squared. Notice that I have a 1/2 that's in the same top and bottom. But let me write these in terms of roots, and maybe we'll see exactly what's going on. So first of all, I can factor a 1/2 out. So if I have a 1/2, and I can also factor a negative sign, right? I've got a negative and I've got a negative. So I'm going to factor a negative 1/2 out. That's even better. So when I do that, I have, this is 1 over root t, because again, it's a negative exponent of 1/2. And this is a positive root t, right? Now, what I'm going to do is, I'd prefer not to have this sort of 1 over root t here. It's kind of cumbersome. And so to simplify this, I'm going to factor out the 1 over root t. Okay? When I do that, remember that to compensate over here, I'm going to have to multiply this by a root t. That one by a root t. This one already has the 1 over root t. Okay? And so let me do that. So careful here. I've got t minus 1 squared. This is a negative 1/2, still out here. I'm going to factor out a 1 over root t. When I do that, let's see what we get. Right? This one I just get a 1, right, because I factored it out. But this one, I remember, I have to compensate by, in some sense, doing the opposite. So I multiply it by root t. And I would have plus, well, root t multiplied by root t is t. So I'd get a t here. Right? And you can verify this by multiplying this back. So clearly, if I multiply this by this, I'd get 1 over root t. Multiply these two together, I would get t over root t. But again, what that means is t to the 1 multiplied by t to the minus 1/2. 1 minus 1/2 is a positive 1/2. So I would get that back again. So now if you agree with me, we're up to this point, I can just write this slightly differently. This whole thing is multiplied by this quantity, so I could write this a little bit differently. I can write this as 1 plus t over well, there's a negative sign here, 2 root t minus 1 squared. Okay, so this is another way of writing the same thing. I just simplified it as far as I possibly could, ultimately. Okay, or possibly if you don't like this, you want to put the negative sign back, we could say this is minus and minus. Okay, but it's okay to write this whole thing as a negative, and you get a 1 plus t up there. Okay, so this is the simplified version, but again, this last bit was just algebra. The quotient rule was just identifying the high and the low and differentiating in the right combination.